AI access is no longer just about who can see data. It's about which models, agents, prompts, and capabilities are allowed to act, under what conditions, and with which safeguards. In this module, we'll focus on the boundaries that keep AI powerful, controlled, and auditable. We've already built the foundation: identity, application security, data protection, and cloud workloads. Now we'll connect those layers to AI-specific access decisions for models, prompts, agents, and capabilities. Think of AI access as a control plane, not a one-time login check. It decides who can use which model, prompt, tool, API, or agent, and under what conditions. That decision combines identity, context, policy, enforcement, and monitoring. The key shift is applying least privilege to AI capabilities themselves. A user may be allowed to ask questions, but not trigger autonomous actions, call sensitive tools, or select higher-risk models without approval. Access governance starts with knowing what you actually have. Every model, agent, prompt template, dataset, vector index, tool integration, and output channel should be treated as an enterprise asset, not an experiment. Once inventoried, classify each asset by sensitivity, criticality, regulatory scope, data origin, and approved use. Then assign clear owners across business, technology, risk, and data stewardship. That metadata becomes the engine for access rules, monitoring, reviews, and exceptions. Model access should be governed by both purpose and sensitivity. A model approved for customer support may not be appropriate for legal review, clinical workflow, or production code decisions. As data becomes more sensitive, access should narrow to trained users, approved applications, and controlled environments. The goal is not to block useful AI. It is to prevent unsupported combinations. The wrong model, used by the wrong person, for the wrong decision, with data it was never cleared to handle. Authorization also depends on context. It is not only about who the user is, but where the request runs, whose data it touches, who pays for it, and which rules apply. A developer may call a test endpoint freely, but be blocked from production. A tenant can use its own model context, not another tenant's. Usage should map to projects and cost centers. Regulated workloads add stricter controls. Same identity, different context, different decision. Model access should not depend on a single checkpoint. A request may start in an app, pass through APIs, hit an AI gateway, and then reach an inference endpoint. Each layer should verify identity, context, policy, and risk. The AI gateway centralizes routing, rate limits, logging, and approved model use. Registries need separate controls for publishing, promoting, and deploying models. This layered pattern reduces bypass risk and gives security teams clear audit trails. Agents shift the access question from what can this identity access to what can this agent actually do. Reading email, retrieving records, drafting a response, updating CRM, and invoking payment are different capabilities with different risk. Observation should be separated from action. Each capability should then be bounded by role, workflow, delegation, risk, and tool controls. The agent should run under scoped credentials, not a broad service account. Once an agent can send email, run code, query databases, or call APIs, it has crossed from advice into action. Every tool call should be treated as a controlled transaction. Start with allow-listed capabilities, then constrain the parameters. Who can be emailed, what repositories can be changed, and how much money can move. Run risky work in sandboxes with isolated credentials. Finally, log intent, inputs, outputs, and outcomes, so every action is traceable and enforceable. Prompts should be governed as assets, not handled as casual text. Start with approved templates for recurring workflows. Then review them against security, privacy, legal, compliance, brand, and safety needs. Test before release, deploy through controlled channels, and version every change like code, so teams can roll back and audit decisions. After deployment, monitor usage and outcomes continuously. The right prompt should also depend on context: user role, data classification, model choice, and policy controls. System prompts deserve even tighter control. They define behavior, safety limits, and tool permissions, so they need controlled storage, access review, and version history. At runtime, user input and retrieved content must never outrank system instructions. Integrity checks and approvals help ensure the deployed prompt is the one you intended. And when a prompt causes safety, accuracy, or compliance problems, versioning lets you roll back quickly to a known good state. Prompt governance also means defining what the system must not accept. Jailbreaks, policy overrides, credential requests, hidden data extraction, impersonation, restricted data use, and unauthorized regulated decisions. Then apply layered review. Automated scanners catch common patterns, while humans review high-impact templates and sensitive workflow changes. Finally, make every prompt auditable. Record the template version, user context, model, data sources, safety checks, outputs, and downstream actions. That trail lets teams reconstruct decisions and detect abuse. Actions should be treated according to their impact. A summary or recommendation may only need logging and review. A drafted email or record change needs human approval before release. When AI can execute payments, deploy code, modify access, or delete data, controls must escalate quickly. Segregation of duties, approvals, monitoring, rollback plans, and sometimes prohibition. If an action affects people, money, legal obligations, or production systems, governance must match that level of consequence. High-risk AI actions should never be reduced to a simple yes or no decision. Start with a request, classify the risk, and require a clear explanation of what the system intends to do. Then apply the right gate: human approval, dual approval, spending or rate limits, and restrictions on recipients or environments. If the policy cannot be evaluated, block by default. After execution, preserve immutable logs and maintain rollback or compensating controls so failures are contained and auditable. AI access architecture is about bounding power. Models, agents, prompts, tools, and high-risk actions all need contextual policy, least privilege, approvals, logging, and rollback. Next, we'll apply these ideas to infrastructure access, privileged operations, monitoring, and the final secure AI reference design. Governed AI is usable AI.